Hi everyone. So now we are going to discuss question setting. So most of you doesn't do not answer this question, so we assume answer. So look at this question. So it's talk about simple harmonic motion. So you have a uniform road which floats vertically in liquid as shown in the figure. It is pushed slightly downwards and suddenly released. So it means that this road is pushed downwards and then released. So these rods will be vibrating in simple harmonic motions. Okay? Define simple harmonic motion. So how do you define a simple harmonic motion? So we know that simple harmonic motions is A directly proportional to your displacement, and the directions of your oscillations is pointed towards equilibrium point. So whenever you answer these questions, if these questions have too much, so you have to mention that the first one is the oscillations directly proportional to the displacement in equilibrium point. Okay, and then the second mark is awarded for your direction towards equilibrium point. So you have to have these few keywords when you are going to define your simple harmonic motions. Next question is, show that the root undergoes simple harmonic motions and ignore damping. So how do you prove that this rod, when it is vibrate, when it is pushed down and vibrate, this motion is simple harmonic motion? How do you prove that? So remember that whenever you want to prove a simple harmonic motions, we start with object in equilibrium. So when it is in equilibrium, okay, when it is in equilibrium, means that the object doesn't move at rest. Okay, the rod is at rest. So this length is the length of the object, length of the rod, submerged in the water. When in equilibrium positions. So this one is L. Okay, when it's in equilibrium, the second thing is we know that the force acted on this rod is balanced. So what is the forces that acted on this rod? So there are two forces. The main force is mg, which is the weight of the rod, and also because it's floating in liquid, so this one is buoyant force. So this is not water, so it should be written in liquid. Okay, so this one, these two forces must be balanced. So in other words, we have in equilibrium, Fb is equal to mg. Okay, then we know that according to Archimedes' principle, Fb, the buoyant force is equal to V rho J. So V is the volume of water displaced, and rho is the density of the liquid, G is the gravitational acceleration. So mention these few symbols. So Fb is the buoyant force. So Fb is the buoyant force, while m is mass of the rod, while V is your volume of liquid displaced, and rho, so I have no place here, so I mentioned it here. Rho is your density of your liquid. Okay, so according to these two equations, so you will have a new equation which is V rho g is equal to mg. So the V is how to calculate your V. So V is water displaced. So the V here is also equal to the volume of root submerged in liquid. So means that this part, the volume here, according to your Archimedes principle, so the V is actually this part. So how do you calculate this V? So V can be equal to A times L. So A is your cross-sectional area. So your A is your cross-sectional area of road, while L is the length submerged in water. So this equation, now this equation will become AL rho G equal to mg. So eliminate G, so you will get M is equal to ALG. So this is your new equation. So we have M equal to ALG. And then now, when the rod is pushed downwards, so after when your rod is pushed downwards, okay, because I have no enough place, so now I want to erase this all the okay. So you just copy down first, make sure you have copied down all the symbols, label all the symbols, don't forget to label. So this equation, now if your rod already submerged in water, so your rod will be go in deeper. So let's say this is your initial L, same as here, and this is after it submerged into the water. So this X is the displacement of the rod pushed downwards into the liquid. So your X is the displacement of the rod pushed down so this is your X. So before that, it's only L is inside the liquid. After you push downward, the rod is pushed downwards. So another displacement is submerged into the liquid. So this displacement we name it as X. So in this time, when the rod is pushed downward, so when the rod is pushed downwards, the equations of this, the force will not balance anymore. but there's two forces acting on it. One is buoyant force, another one is still your weight of the rod, but now it will be vibrating. So when it is vibrating, so this is your x displacement, the displacements of your x, and this is your directions of your a, which is always opposite to your x displacement. So the equations will become mg minus fb equal to ma. Why? Because your mg is in the same direction of your x, so your mg should be positive, while your fb is negative because it's opposite directions to your increasing x. Okay, I repeat, mg is in positive because your mg and x are in the same direction. Your mg and x is in the same directions, while your fb and x is in opposite direction. Thus, your equations for this, for the resultant force, acting on the rod will become mg minus fb equal to ma. So we know that mg, your m is equivalent to this equation, which is ALG. Sorry, it's AL rho. Make the mistakes here. It's AL rho because the G already eliminates. You have your AL rho for your m. So your m is AL rho times 3 minus FB. FB is still V rho G, which is your A L plus X 3. Why? Because A times L plus X rho 3. Why? Because your V now is the volume displaced by the object, which is here. This volume. So how do you calculate this volume? So this volume is equivalent to V is equal to A times L plus X. So substitute inside, you will get this equations, and then this one will become NA. So open the bracket. So you will have AL rho G minus AL rho G plus AX. Sorry, minus AX rho G. Equal to NA. Sorry. So this one will be eliminated. So your NA will be equal to A negative AX L AX rho G. So A will be equal to negative AX rho G divided by M. And you know that M is equivalent to negative AX rho G divided by AL rho. So cancel out. So you will have X G over L negative. So now you have proved that A is directly proportional to negative X. Thus, it's a simple harmonic motion. Okay. Now, second part of this. The third one is write down the expressions for the periods of oscillation. So how do you write down the expressions for the periods of oscillation? So you know that A is directly proportional to negative x and A is equal to negative omega square x. So omega square can be written as 2 pi per t. So the equation will become negative 2 pi per t square. X is equivalent to the negative g per L x. In other words, your 2 pi over t square is equal to g per L. So now you have your 2 pi over t as square root of g per L. Then t will be equal to 2 pi square root of L per g. So this shows that your t will be equivalent to 2 pi square root L per g. Okay, so these are the answer for your questions 18. Well, next for question 3. A particle of mass 0.20 kg executes simple harmonic motions. Its displacement x changes with time t according to the relations 10 sine 10 pi t, where x and t are measured in centimeter and second respectively. So we know that this one is in centimeter and second, means that when you are calculations, the answer must be in terms of centimeter and also second. Okay, now you want to find the speed of the particle at t equals to 1.20x. So you are given the displacement. This is your displacement. But we want you to find v when t equal to 1.20 second. How? So you have to differentiate your x with respect to t. So you differentiate this equation, so you will get 10 times 10 pi sine become cos, differentiate sine become cos. So you have your cos still 10 pi t. So substitute this one, so you will get 100 pi cos 10 pi t. This one is your v. So when your v, how do you find your v when t is equal to 1.020s? So substitute your t equal to 1.20, so you will get 100 pi cos 10 pi. T is 1.20, substitute inside and you press your calculator and you will get your answer as 314 centimeter per second. And don't forget that this equation, when you press this in your calculator, make sure this is in radian. Okay, make sure your calculator is in radian form. Okay, now we proceed to the second questions, where I want you to find the force that acts on the object or particle when your t is equal to 1.85 seconds. So how do you find? So we know that F is equal to ma according to Newton's second law. So when F equal to ma means you have to find your a is equal to some value when your t is equal to 1.85 seconds. So get your a first. So how do you get your a? So a is actually differentiations of your velocity or the rate of change of the velocity. So you differentiate your v equations and you will get your a. So differentiate this one. So you will get your 10 times 10 pi, another 10 pi, but now becomes sine omega t. So this 10 pi t, and because cos is differentiate into s, it's negative sine. So add up a negative, so you will get 1000, negative 1000 pi square. Okay, negative 1000 pi square sine 10 pi t. This one is the a. So substitute t equal to 1.85. So your equations will become like this. 10 pi. So your t now is 1.85. So substitute inside. Don't forget, still here you must make sure your calculator in radian form. So you will get your A as equal to negative 9869 centimeter per second squared. But you want to get A, so you have to convert your answer into meter, because when you are using F equal to MA, so you have to make sure your unit is in SI unit. In other words, A will be equal to 9869 times 10 to the power of negative 2 meter per second squared. Substitute inside F equal to MA, so your M is 0.20 kg, which is mentioned in this part. So you have your 0.20 as your M, then you substitute 9869 times 10 to the power of negative 2, then you will get your answer as negative 19.7 Newton. Okay, so that's it for this questions.